Today I am going to tell you 10 important key points from the Hidden Reality documentary based on the book of same name by Brian Greene. In this documentary series, Greene takes viewers on a journey through the history of physics and the cutting-edge theories and concepts that are shaping our understanding of the universe. Here are 10 key points from the documentary. The first key point is the idea that there may be additional dimensions beyond the familiar three spatial dimensions: length, width, and height, and one temporal dimension, time, is a provocative one. However, it is not a new idea, as scientists and philosophers have speculated about the existence of higher dimensions for centuries. The notion of extra dimensions is one of the central themes of The Hidden Reality, and is discussed throughout the book and documentary. In physics, the concept of dimensions refers to the number of independent parameters required to describe a physical system. For example, to locate an object in space, we need three independent parameters: its x, y, and z coordinates. To describe events that occur over time, we need one additional independent parameter: time. However, there is no reason to assume that there cannot be additional dimensions beyond the four we experience directly. One possible reason why we have not yet observed these additional dimensions is that they may be too small to detect directly. According to the Kaluza-Klein theory, the additional dimensions are curled up or compactified, which means they are wrapped tightly around each other and too small to be visible on the scale of our everyday experience. However, they may have observable effects at a much smaller scale, such as in the behavior of subatomic particles. The second key point is the Kaluza-Klein theory, developed in the 1920s, proposes that the universe has more than four dimensions. But the additional dimensions are curled up or compactified, meaning they are tiny and tightly wound up in a way that makes them unobservable to us. The theory was developed as an attempt to unify the electromagnetic and gravitational forces in a single framework, which could only be accomplished if there were additional dimensions beyond the four we experience directly. In the Kaluza-Klein theory, the extra dimensions are assumed to be circular or cylindrical in shape, with a very small radius. The theory proposes that particles and forces that we observe in our four-dimensional universe are actually the result of vibrations of these compactified dimensions. While the Kaluza-Klein theory was initially developed as a way to unify the fundamental forces of nature, it has since been used to explain the existence of extra dimensions in other theories, such as string theory. The third key point is in addition to the idea of compactified dimensions. Another possibility for the existence of extra dimensions is the concept of parallel universes. This idea suggests that our universe is just one of many universes that exist in a higher dimensional space. One way to visualize this idea is to imagine a sheet of paper. In our familiar three-dimensional space, we can move up and down, left and right, and forwards and backwards. However, if we add a fourth dimension, we could move up and down, left and right, forwards and backwards, and also in and out of the page. In the theory of parallel universes, our universe would be like a sheet of paper, while other universes would be like other sheets of paper stacked on top of ours. Each sheet would represent a different universe with different physical laws, properties, and histories. Another way to think about parallel universes is through the concept of brains. A brain is a membrane-like object that exists in a higher dimensional space. In this theory, our universe is a brain that is embedded in a higher dimensional space, which could contain other brains representing other universes. The interactions between these brains could give rise to observable phenomena, such as the properties of dark matter and dark energy. The concept of parallel universes is a fascinating and provocative idea, but it is also highly speculative and difficult to test experimentally. Nonetheless, it has captured the imagination of many physicists and cosmologists and has become a popular subject of science fiction and popular culture. The fourth key point is as follows. The string theory is a theoretical framework that seeks to unify all the fundamental forces and particles of nature into a single, coherent theory. One of the central features of string theory is the idea that particles are not point-like objects but instead are tiny, vibrating strings. In string theory, the properties of particles and forces are determined by the way these strings vibrate. Different modes of vibration correspond to different particles and forces, such as photons, electrons, and gravitons. One consequence of this is that the number of particles and forces in the universe could be explained by the number of different modes of string vibration. Another consequence of string theory is the possibility of extra dimensions. In the theory, the strings that make up particles are not confined to our familiar four-dimensional spacetime but can vibrate in additional dimensions. The existence of these extra dimensions could help explain some of the puzzles of modern physics, such as the nature of dark matter and the apparent discrepancy between general relativity and quantum mechanics. String theory also provides a potential framework for the existence of parallel universes. In some versions of the theory, the different universes correspond to different ways that the strings can vibrate in the extra dimensions. However, string theory remains a highly controversial and speculative idea, and there is currently no experimental evidence to support its predictions. The fifth key point is as follows. As mentioned earlier, one of the key features of string theory is the idea that particles are not point-like objects but instead are tiny, one-dimensional objects called strings. These strings can vibrate in different ways, which give rise to different particles and forces. The vibration modes of a string determine its properties, such as its mass, charge, and spin. For example, a string that vibrates in a particular way might give rise to a photon, while a string that vibrates differently might give rise to an electron. The concept of strings as the fundamental building blocks of the universe is a departure from the traditional view of particles as point-like objects. It also has implications for the nature of spacetime, which could be seen as an emergent property of the interactions between strings. The sixth key point is the idea of extra dimensions is a central feature of string theory. In the theory, the strings that make up particles are not confined to our familiar four-dimensional spacetime but can vibrate in additional dimensions. The number of extra dimensions required in string theory varies depending on the version of the theory. Some versions require as many as 10 or 11 dimensions, while others require fewer. However, all versions of the theory require more than the 4 dimensions that we experience directly. The existence of extra dimensions has important implications for the properties of particles and forces. For example, the behavior of particles could be influenced by interactions with other particles that exist in the extra dimensions. In addition, the existence of extra dimensions could help explain the apparent discrepancy between general relativity and quantum mechanics, which are currently incompatible in our four-dimensional universe. The idea of extra dimensions is also closely related to the concept of parallel universes. In some versions of string theory, the extra dimensions could be large enough to contain other branes representing other universes, which could interact with our universe in various ways. The seventh key point is as follows. Spacetime is the fabric of the universe, in which all matter and energy exist and interact. In classical physics, spacetime is treated as a fixed and absolute framework in which all events occur. However, in modern physics, the nature of spacetime is much more complex and mysterious. According to the theory of relativity, spacetime is not fixed but can be curved and distorted by the presence of matter and energy. Furthermore, in quantum mechanics, spacetime could be fundamentally different from our everyday experience. Some theories suggest that spacetime is made up of discrete, indivisible units called Planck length, and that it could be emergent from the interactions of underlying quantum fields or strings. The nature of spacetime is a key question in modern physics, with profound implications for our understanding of the universe and the nature of reality itself. The eighth key point is the concept of the multiverse is an extension of the idea of parallel universes. It suggests that our universe is just one of many possible universes, each with its own unique properties and characteristics. There are many different versions of the multiverse hypothesis, each with its own set of predictions and implications. Some versions suggest that the different universes could have different physical laws, constants, and even numbers of dimensions. The multiverse hypothesis has become a popular topic in both science and science fiction. However, it is also highly speculative and controversial, with no direct experimental evidence to support it. The ninth key point is as follows. The anthropic principle is a controversial idea that suggests that the properties of our universe are finely tuned to support the existence of intelligent life. According to this principle, if the physical constants and laws of our universe were even slightly different, life as we know it could not exist. For example, if the strength of the electromagnetic force were slightly different, atoms could not form stable structures, and complex molecules necessary for life could not exist. Similarly, if the expansion rate of the universe were too fast or too slow, the formation of galaxies and stars would be impossible. The anthropic principle has been invoked to explain the apparent fine-tuning of the universe. But it remains a highly controversial and debated idea. The 10th key point is as follows. The holographic principle is a fascinating idea that suggests that the information in a volume of spacetime could be encoded on its boundary, like a hologram. According to this principle, the universe could be thought of as a hologram, with all the information contained in its boundary or surface. This principle has profound implications for our understanding of the nature of spacetime and the relationship between gravity and quantum mechanics. It suggests that the universe could be fundamentally different from our everyday experience, and that our current theories of physics may need to be revised or replaced. In conclusion, The Hidden Reality, by Brian Greene, is a thought-provoking exploration of some of the most fascinating and controversial ideas in modern physics and cosmology. From the existence of parallel universes to the nature of spacetime and the possibility of extra dimensions, the book offers a compelling and accessible introduction to some of the most cutting-edge theories and concepts in physics today. These key points highlight some of the most intriguing ideas discussed in the book, but they are by no means an exhaustive list. The Hidden Reality covers a wide range of topics, from the history of physics to the latest research in string theory and cosmology. Overall, the book challenges readers to question their assumptions about the nature of reality and invites them to explore the fascinating and often mind-bending ideas at the forefront of modern physics. Whether you are a seasoned physicist or a curious layperson, The Hidden Reality is a must-read for anyone interested in the mysteries of the universe. And that's the end of the documentary. Thank you for listening.